Does it make sense to do DevOps, or to what extent does it make sense to do DevOps if you're working on an embedded system?
Ladies and gentlemen, the tiny DevOps guy.
Hi, everyone. Welcome to another episode of Tiny DevOps, the show where we believe you don't need 1,000 engineers to do world-class DevOps. I'm your host, Jonathan Hall, and today I have with me special guest Luca Ingianni, who is the co-host of a couple of other podcasts, one on embedded Agile, which is closely related to what we're going to talk about today, DevOps on embedded systems. And the reason I want to talk about this is one of the common complaints I hear people make about DevOps, or maybe not complaints, but detractors, is DevOps only works if you're doing web software, or if you're doing SaaS, or if you're doing something like that. And I understand why they might say that, because certain types of software don't have an operations component, or at least not the same type of operations component. But I want to challenge that assumption. And honestly, it's an assumption I've made in the past. One of my email boot camps, I make a claim about, I think it's continuous deployment. And I say, on the other hand, if you're building firmware for diesel fuel injectors or pacemakers or self-driving cars, these rules may not apply to you. So you have more experience in this area. So I'm hoping you can either tell me I'm completely wrong and we can still do DevOps in these areas, or maybe I'm actually right and I just happen to guess right. In any case, today you're the expert on this topic, so I'm hopeful that you can shed some light. But before I go too far into that area, Luca, why don't you introduce yourself and tell us about what you do?
Yeah, so hi everyone, I'm Luca Ingianni. I'm actually an aeronautical engineer by training, so I kind of, I just tumbled into IT and never quite found my way back out as these things happen. And maybe that has influenced my thinking a little bit and my perspective on a lot of things that I see in IT. And I started my career in embedded systems, like helicopter avionics, that sort of thing. I sort of, by accident or by necessity, stumbled upon what I now know is called DevOps, even though I wasn't familiar with the term at the time. It just came about as, something that felt necessary for me and my colleagues to improve our practices and get better at building helicopters or whatever it was we were doing. And then eventually, of course, I found out that somebody had stolen all of my ideas and called them DevOps. And I seem to have a knack for explaining engineering, like techniques, thought models, etc., to engineers and to non-engineers. And so this is what I've made my profession now. So instead of being a mediocre engineer, I try to be a somewhat better trainer, coach, mentor, whatever you need to, improve your development practices.
So when did you discover DevOps and discover that somebody had stolen your ideas? What time frame was that?
Well, of course, it wasn't like a single instant. So it sort of accreted over the years. I know that I used Hudson back when Jenkins was still called Hudson. That must have been like 2010-ish to do continuous integration, back when that was still something very few people considered seriously. Just because I felt that I needed to have some kind of technical underpinning to improve my cycle times. And then, of course, over time, I came to the realization that, this only gets me so far. I actually need to improve the practices of me and my colleagues, all the other stuff that surrounds the technology. I guess that sort of took me a couple of years, probably until 2015, I would guess, until I realized that by accident I'd become a DevOps guy.
Okay. I think that's a common story among people who are doing DevOps, that we were doing all these things all along, and then we realized there was a name for it. So before we dive into the details, just at a really high level, does it make sense to do DevOps, or to what extent does it make sense to do DevOps if you're working on an embedded system?
I guess in order to answer that question, we need to take a step back and agree on some kind of a definition for DevOps. Because I think this is what some of the confusion stems from. Like, I don't think you will ever see Kubernetes installed on a fuel injector. Or I sincerely hope that will never happen. If we think of DevOps as a set of technical practices, continuous integration, Kubernetes type stuff, whatever, then maybe you can make the case that some of that is not technically suited very well to an embedded environment. But if you broaden your view and you say, there's a lot of processes attached to this, there is a lot of mindset of culture attached to that, which is the view that I take, then of course it makes perfect sense. Because at the heart of it, DevOps is just this mixture of lean and agile and all those practices that come from traditional engineering and are at their core about, risk management. And of course that's a good thing, no matter what you do. And certainly your practices might look a little different. But all of the fundamental thought processes apply just as well. Why wouldn't you do continuous deployment for an embedded system, especially if it's something as benign as a kiosk? Maybe if it's a pacemaker, then you should be more cautious about what you're doing. But even in the context of a pacemaker, if you've done your job right, there's actually nothing fundamentally scary about continuous deployment to pacemakers, because at some point you're going to deploy anyway, and you're going to be as certain as you can that you've done your job right before you do. So the pure act of deploying, that doesn't change that. Either you missed a bug or you didn't miss a bug, whether you have a manual deployment decision or not.
Yeah, that's one thing I always try to drill into the teams I'm coaching on, especially continuous deployment, is putting a manual check in there usually doesn't actually add any safety. Somebody's making a choice one way or the other. They're either making it when they hit that merge button, or they're making it at some point later, probably removed from the code they're creating, and making it with less information. So it sounds like you agree with that. Even in the case of a pacemaker, it still is true.
Yes, of course. And, all of the risk mitigation happens long before somebody clicks deploy or doesn't click deploy, as the matter may be. All of your tests must have concluded long before that. All of your designs, your safety critical designs must have happened long before that.
That's great insight, that your risk mitigation must happen before. Yeah.
To speak to your thing about when the deployment decision happens, I think with continuous deployment, the deployment decision happens, long before somebody clicks on merge or whatever. It happens as you install your continuous deployment script. That is when you make the business decision. We are going to deploy as soon as we are technically able to. You could make other decisions. You could make the decision of, to wait until it's Monday morning, for instance, so everybody's in the office and you can catch issues as soon as they appear. That's also a valid decision. You made the decision to not wait at all. Business decision, not a technical decision, not a risk mitigation decision.
Talk about that. You say it's not a risk mitigation decision because most people frame it as such. Where are they wrong?
And I understand those people. It does feel scary, doesn't it, to not have any way of stopping this train once it leaves the station. But you really have to ask yourself, what are you gaining from waiting until a later time? If you do some manual exploratory testing before you actually deploy into production, okay, fine. Then you do in fact mitigate some risk, and that's a valid decision. Nothing wrong with that. But if you don't, if all you do is stick your newly created artifact in a bucket and at some later point reach into the bucket and stick it into production, you might as well reach into the bucket right now. There's no difference. There's only a difference in your head.
Do you have an example, maybe a story of a time when you've been working on an embedded system and you started to apply DevOps principles that you could share with us to give context to the rest of this conversation?
Mm-hmm. Yeah, so one project I worked on a couple of years ago, I tried out a lot of this DevOps stuff. Realized that I had just realized that I was doing DevOps, so I was all in on the DevOps thing.
Of course.
So anyway, let me explain to you what this product was. That was actually a fairly awesome machine. It's called a wire bonder. So it's, broadly speaking, it's a kind of industrial robot that is used in microchip production to make electrical connections from the actual silicon chip to the pins. And they are connected with tiny little wires, literally hair-thin wires placed with micrometer precision and ultrasound welded on. Then you put the wire on the other spot, weld it on there, and then yank the rest off. And you do that very quickly, of course. So awesome machines, really precise, really fast, lots of confusing constraints. You can't just move your robot arm whichever way you want. Maybe you might bump into other components, and that would be really bad. So very interesting machine. And as being a proper machine, it had a lot more complexity to it than only software. Of course, we had complex software, with pathfinding algorithms, and we needed to, calculate breaking points and sense the surface and all kinds of things. But also we had electronics in there, from power electronics, big strong servos that literally took somebody's finger off once, to tiny little sensors and very, very sensitive scales. And we had mechanics, we had hardware, we had a big beefy frame. Imagine this thing is as big as a cupboard or something.
And when you joined, what was the state of operations development? What were the practices they were going through when you joined? And then how were you able to improve that?
Well, this was a fairly remarkable company. They're fairly successful. They are one of, a few companies worldwide that are able to build those machines. But they were very sort of set in their ways, as it often happens in embedded systems. You get electrical engineers or mechanical engineers, and somebody finds out one of them can sort of code in Turbo Pascal or something. And so they're now the head of the software department. So they were very behind, as often is the case in the embedded industry, where, like the electrical engineers who wrote the firmware didn't have version control. That was in 2018. And actually, it is a testament to their skill that they were able to not make a mess of it. But boy, were they making their life harder than it needed to be. So essentially, there was nothing. We had very little in the way of formal QA. We had very little in terms of version control, in terms of, software development processes. And I was trying to set some of this up. And of course, that wasn't my official mandate. I was there as a requirements engineer, but they just drove me mad. I think I needed to do something about this.
Yeah.
And so, we got to the point that we had automated unit testing. We had automated integration testing, and also testing on the target system. In embedded systems, you typically, you develop on a PC and then you flash onto a potentially really tiny microcontroller with like a kilobyte of RAM or something. So that's called the target in embedded systems speak. So we had testing on the target. We were working our way towards actual product level tests, BDD style tests. So there was a lot of movement sort of across the board, I think, towards more modern practices.
Were you doing continuous deployment, continuous delivery? Continuous
deployment didn't make sense just from a standpoint of the hardware landscape. Our devices were not set up for that. We could have rigged something to make it work. I don't know, with Docker containers that contain the the actual like firmware or something. But we didn't get that far, and it didn't make sense because most of those industrial systems are on, if they are networked at all, they are on very separate networks, not connected to the open internet. So, at some point, a truck would come and pick our device up and drive it away. And that's, after that, you don't get to deploy anymore unless you give a support engineer a USB stick and send them on a plane.
So were you at least able to do continuous delivery in the sense of every build would create an artifact that was deployable?
Yes, we were. But that was the interesting lesson I took from that, which was that there was no point because the rest of the organization didn't know what to do with that. We were able to drop them new artifacts every half hour if you wanted to. But there was nobody to give them to in an organizational sense. Like everybody else kind of did their own thing, was working in their own silos at their own pace. And, we were merrily throwing out new iterations to nobody really.
Okay.
Which is the big lesson, I think, that DevOps feels like it's an IT topic and, a topic for the IT organization. It isn't. Right. It's much broader than that. And that is something that that I've often heard in conversations with other DevOps managers, leaders, whatever, that the biggest surprise was finding out that introducing DevOps to their own part of the organization, to the IT organization, was, well, maybe not easy, but it was sort of, straightforward, and they knew what they were getting into. But the big surprise was that they needed to make it work for the entire rest of the organization.
Yeah, so you're absolutely right. I mean, DevOps, we often say, often with frustration in our voice, that DevOps is a culture or a cultural shift, not a technical shift. And we usually say that when we've done the technical stuff and the DevOps is still failing in some way, right? Mm-hmm. Like, well, we did all the technical stuff, but it's still not DevOps. Why not? So, and I think we recognize in the back of our minds usually that it's about a culture change. But then that's always frustrating when we can't make that change in other parts of the organization. You also made a point that brings me back to my original sort of the premise that a lot of people assume that DevOps doesn't work in non-web or non-SaaS software. And part of the reason I think people assume this is because operations and what you're describing, the operation, so to speak, of what you're describing involves a forklift and potentially a representative on an airplane, right? That's operations in your product here. Even so, what I hear you saying is that even though maybe technically in the dictionary sense, DevOps isn't happening here, most of the principles up to the point of basically continuous deployment and continuous delivery are still valid. The idea of streamlining your work, shorter feedback loops, automation, things like this. Would you agree?
Oh, definitely. So first of all, I just want to point out that this kind of problem with deployment is not unique to embedded systems. If you think of Microsoft Word, even Microsoft can't make a deployment decision on behalf of the customers. You decide when you click on upgrade or whatever it is. And they're trying to move away from that, but fundamentally, this is not not a very unheard of scenario. And so, yes, you're right that technically in this particular scenario we didn't have ops, so it couldn't have been DevOps, and technically you would have been right, but also you would have been very boring, because we're still doing engineering, we're still thinking in terms of value streams, or we should be anyway. And yes, of course, some things will look different. Like, also we are working with hardware, and hardware just has longer cycle times. If I design a new board layout, PCB layout, and I want to actually turn it into a prototype, I need to get that sent off to be etched and to be, to have the components placed on it, and then it gets sent to me by mail, because how else? That whole thing just takes a week or two. So my cycle time by necessity is 2 weeks plus whatever time I need to actually do software, do my actual design. So yes, it looks different. So what? Of course it will look different.
Let's talk about some of the specific practices you've done and how they applied to this project. So, and maybe we could just sort of start at the left of the product cycle and work our way towards deployment. So you mentioned unit testing. I imagine that when you say unit testing, you mean testing individual functions that didn't matter that this was on an embedded system versus some Java runtime or whatever else. Did you also have automated tests that did depend on the hardware environment?
To a degree. Like, of course, eventually you'll bump into an interface to the actual hardware. And if the actual hardware is not there, then, what do? Either you mock it out or you just don't test that sort of thing. That's also a valid decision. We did unit tests for essentially everything. I was also working in a real-time environment. So we had a central control loop that ran at 16 kilohertz, which is really fast even for embedded systems. So come hell or high water, we had to be done with all of our work in the worst case scenario in 62.5 milliseconds. And if we didn't, and we missed the deadline 3 times in a row, then the scheduler would notice and would just yank power from the system. That's sort of, just very timing dependent stuff is testable in isolation, in the shape of unit tests, but it wasn't worth the trouble.
You also said when you started, they weren't even using source control at all. What steps did you make in that direction? I'm assuming that you did use source control at the end.
Yeah, so the software department, the people who wrote the high-level control software, they were already using source control. I think they were using CVS, and they were sort of in the process of moving to Git. The embedded, or rather the firmware folks, they were aware that they should start using version control. They just, as it happens, they just never got around to it.
Always, I hear a lot of people ask me questions like, how do I convince my team to do X, where X is something that would improve productivity, or at least the person asking believes so. And this is a good example of that, I think, or could be. You convince them by addressing a problem they're feeling. So
this was the first time I sort of consciously started to introduce DevOps somewhere, and I didn't do it as well as I might have. So I guess the lesson that I took from that was that I should have been both more forceful in going for DevOps practices and saying, no, this is how we're going to do this. You should really be doing this because it will have advantages for you. And at the same time, doing exactly this other thing that you pointed out, which was making it really clear what was in it for an individual engineer. Like the firmware folks, I should have been really plain about, okay, you're going to waste a week learning Git. You go, however long. And you're going to mess up every now and then until you finally get the hang of it. And, it's going to be annoying and tedious. But in return, you will get this thing, which was very difficult before, to be really, really easy. Wouldn't that be nice? I think it's reasonable for everybody involved to be egoistic about this and say, look, what do I gain from this?
What kind of monitoring did you have in place? Because that's another part of DevOps that often kind of gets swept under the rug. And we already discussed that your operations was kind of a different beast than a typical DevOps organization. But I wouldn't be surprised to hear that you had some sort of monitoring in place, or maybe that monitoring was your customer service department. When something went wrong, they would call you.
By necessity, a lot of it was the customer service department, because we, once the forklift comes and takes the machine away, then it's gone. And we can't really look at the logs. But yes, the machines themselves collected a lot of logs, both on a technical level and also on a manufacturing process level. They would know how well all of their movements worked, etc., etc. And that tended to be analyzed at the customer's plant by their process engineers. And of course, if they spotted a problem, they would call us, and we had ways to assemble all of the logs and all of the data and stick it into zip file and put it onto a USB stick, and then, we could use SneakerNet to walk over there, take the USB stick, stick it into another machine that was connected to the internet, and they could mail it to us, and we could have a look. What we could, of course, have been doing would have been to be much more, to do much more monitoring on a development process level. And we had sort of started that. We tracked metrics like test coverage, that sort of thing. It's amazing. This was not a big company. They had maybe 20 engineers total or something. We all knew each other, of course, and we would bump into each other at the coffee machine. But there was not much visibility into what everybody was doing. I wish I would have been more forceful about changing that. And I don't even know what that would have meant, a company-wide Kanban board or something. Like, we could have fit the work of 20 engineers on a common Kanban board.
How do you think DevOps should be affected, or the way we do DevOps should be affected when you're dealing with life or death situations, say a pacemaker or a self-driving car or the space shuttle or something like that, where human lives are on the line? How or should that affect the way we apply DevOps?
That's an awesome question. And it's a very difficult question. Like, one of the things we are aiming for in DevOps, of course, is more frequent deliveries, more frequent updates, which is a good thing, of course. But on the other hand, it is fraught with some risk that, you change the behavior of the system, which is exactly the point, of course. But it forces your users to keep learning and to keep sort of being aware of those changes. And that's fine if you're building a soda machine or something. But I'm always reminded of this accident that happened maybe 3-4 years ago, where a Tesla owner was driving down the road in autopilot mode, and it was a road that they'd been driving literally every day. It was part of their commute to work. And, Tesla had installed an update for the autopilot, as they do, just over the air. And as it turns out, this autopilot update had introduced a change that I find eminently reasonable. Apparently, it used to be that autopilot would look at the left-hand side lane divider and follow that to keep lanes. And now they said, you know what, we're going to find the left-hand side lane divider, and we're going to find the right-hand side lane divider, and we're going to center ourselves in there. Makes a lot of sense. You drive nicely in the center of your lane. Perfect. Until, of course, the road split, and the car just sort of nicely averaged itself into a barrier that was at the center of that road split. Very reasonable change, and no observable behavior, a change of behavior, as far as the driver was concerned, until, at the last second, the car just didn't veer left as it used to. Instead, just continued straight on, and unfortunately, the poor driver died. And this shows to me that we, in fact, as a society, need to learn ways to deal with machines that all of a sudden can change their behavior without any sort of advance notice or without any sign. Like, if a mechanical thing looks different, we can tell, oh, that might behave differently. I should pay attention. But the car looked just as it did yesterday. And over-the-air updates, yes, good idea. They probably fixed a bunch of bugs that could have led to accidents otherwise. So, yes, over-the-air updates, also good idea. But what do we do about those behavior changes? I think we as a society need to find a solution to that, because I can't see a technical solution. Like, we can't make drivers read change logs before they start their drive. Like, that, nobody does that. So I think fundamentally, applying DevOps principles to something that interacts with the real world, as embedded systems do, changes the rules of the game, in ways that we have not yet quite understood, I think.
I agree. I guess there's no answer today. We need to hash this out over the next decade or so as a society at large, right?
Yeah, exactly. That's going to be, yet again, an interaction between like the creators of such devices and the users of such devices on how do we deal with changes that somehow break behavior in unexpected ways, in ways that are maybe dangerous or maybe just annoying,
what advice can you offer to somebody who wants to start implementing these things and maybe they're struggling? Maybe they're in the same situation you were in when you joined this team. Maybe they're excited about DevOps. They're trying to implement it on their team, whether it's an embedded team or a SaaS team or whatever. What do you suggest?
So fundamentally, I think the important thing is to get started somewhere and then sort of build outward. If you don't have version control, maybe start there. If you already have it, maybe the next step would be CI, whatever. Sort of keep building more parts to the system, but do it in an intentional way. Don't install CI for the sake of having installed CI. Know what you're going to do with it. Know what you're going to do with the feedback. If you don't build an organization that is able to deal with this fast flow of feedback, then all you've done is install new software and now you get to maintain it and it won't really change anything. So I think this is the important point, to be intentional about how to employ tools to improve your practices, your processes, your philosophies. And then just keep learning and keep iterating. Of course, if you want to learn more about this sort of thing, I have an entire podcast for that, which is called the Agile Embedded podcast that I'm doing together with Jeff Gable, who's a much better engineer than I am, where we talk about these kinds of things at length.
Good resource. And I've listened to the podcast a few times. It's very informative. Highly recommended.
Thank you.
Any other resources you recommend, whether it be about embedded or just DevOps in general, for somebody in this situation?
Yeah, so there's a book that I might recommend, which sounds like it's very specific, but it's actually a lot broader than it first appears, which is called Test-Driven Development for Embedded C by James Grenning. And as it turns out, James Grenning is one of the original signatories, is that how you say it? Of the Agile Manifesto. So he's a dyed-in-the-wool Agile practitioner, and he's a hardcore embedded systems guy, and he can write very well. This is a really interesting book that sort of builds up TDD from first principles, both in terms of code and in terms of practice, and makes it sound shockingly simple, which it is. So it's a really awesome book for somebody who's, maybe dabbling in those kinds of low-level work and just wants to look behind the scenes of what the TDD framework is doing or something.
Is embedded C a prerequisite? I mean, if you're not using embedded C, will you still get something from the book?
Yes, you will. So I guess it helps if you're fluent in C or fluent-ish in C. But even though all of the examples are geared towards embedded, at that low level, at the level of, unit testing, it doesn't really matter what it runs on, does it?
All right, Luca, thank you so much for coming on. How can people get a hold of you or get in touch with you if they're interested?
Yeah, so since Jonathan already noticed that my name is kind of hard to pronounce, I went for a much easier URL. So you can find me at luca.engineer. Luca is Luca.engineer. That will take you to my website where I try to write blog posts and where you can certainly catch me, write me an email or something to, ask me questions. As you can tell, I like to talk about this sort of thing. Don't hesitate to reach out. Don't hesitate to ask me any questions. I'd be delighted to hear from you.
Luca, is there anything else you would like to add that I failed to talk about or failed to ask about that you think our listeners should hear? Maybe
it just can't be repeated often enough that there is really no excuse for not moving towards DevOps. Whatever that means for your concrete situation. Yes, you're not a web startup. Yes, you're doing, I don't know, you're a small shop, or you're doing embedded, or you're building spaceships, whatever, it doesn't matter. You will find a way to apply the principles and philosophies of DevOps to your situation, to your engineering position, and you should. Great. You heard it from the expert. Start doing DevOps. Yep. All right. Wonderful. Thank you, Luca. It's been a pleasure talking. I've learned a lot. I hope our listeners have too. Thanks for coming on today. Thanks for having me. This was a lot of fun.